Okay, guys, so I'm going to show you guys how to do numbers 1 and 2. So you see number 1 pretty much pre-made and done based on the introduction video. So how did I get here? This is from the insert drawing, and then you will select new, okay? And then I click edit. Well, you guys will be able to click edit because I already done it for you. But this is where I added the shapes and the arrows and then the text box to be able to enter the information. Okay, so number 1, I typed in M equals 10 kilograms because that's the mass. We have the A is what we're looking for. And we have a 5 newtons force going to the right. We're just going to assume going to the right. And then we have 3 of the frictional force that's on the opposite direction. So we're looking for acceleration. Then we have mass, and then we have 2 forces. So when we have more than one force in that same plane, like horizontal plane, then we need to find the overall force. We do that by subtracting if they're in the opposite direction. So 5 minus 3 gives us 2 newtons. That is our net force. That is our F that we will use in the calculation. Okay? So based on the triangle, our F was on top and our M is at the bottom. So we will have 2 divided by 10. Okay? So 2 divided by 10. F equals F slash M is equal to 2 divided by 10. Okay? When you do that division, 2 divided by 10, you're going to get 1 over 5, or it's going to be 0.2. Okay? And you just put that information in the box when I see it. If you want, just so it can make it easier for me to see, just highlight or change the color of it. How do I change the color? Right here. Okay. So I will make this red just so I can see that this is your answer. Okay. Here, number 2, we have Henry and Sam. They're playing tug of war. And they're pulling a rope that's 5 kilograms. So you see M equals 5 kilograms. Henry is pulling with 15 newtons. Since we know his information, we're just going to assume that it's towards the right. We need to find Sam's force if the acceleration of the rope towards Henry is 2 meters per second. Well, if the rope is going towards Henry, it almost feels like he has the bigger force. Okay, so before we go there, let's try to solve for Sam's force. Okay, so we have the mass, we have the acceleration. So we know in order to solve for force, it's mass times acceleration, which is 10. Okay, so that means that 10 is our net force. That is the overall force that is happening on the rope. Our issue is we need to find out what is Sam's force, this missing number here. Okay? So if my net force is 10, but Henry has 15, then what is Sam's force? So 15 minus some number is going to give me 10. Well, what number is that? 5. Okay, so that means Sam's force is 5. I want to mark this red. So 15 minus 5 is going to give us that 10 net force that we got when we multiplied our mass times acceleration. Okay, luckily for you guys on the computer, you can copy and paste this drawing, this free body diagram for each problem. Click edit and just put the information that you have. That way you'll be able to see what you need to solve.